Assalamualaikum warahmatullahi wabarakatuh. So we continue our lesson. So today we want to look about cell potential, E cell. So what is E cell? E cell is the difference in electrical potential between the anode and cathode is called cell voltage or electromotive forces EMF or cell potential. So, semua ini diukur menggunakan voltmeter. It acts as electrical pressure that pushes electron through the wire. And then, what is standard cell potential? Standard cell potential. The electromotive force EMF of a voltaic cell measured under standard condition. So what is the formula for standard cell potential? E naught cell equal to E naught cathode minus E naught anode, or you can use E naught cell equal to E naught reduction plus E naught oxidation. But you just stick to the one formula, right? Which is this one, E naught cell equal to E naught cathode minus E naught anode. For example, we have this cell notation. Alright, first of all, you have to write the reduction equation for the two half cells. So from the cell notation, we know that this side is anode. Alright, so this side is anode. And then another side is cathode. But then for this one, we tulis both in the reduction process because the value E not given here is SRP value, standard reduction potential value. That means both here equation in reduction process. Alright. Identify the anode and cathode. Okay, from the cell notation, the anode, the cathode, the cathode here is copper. The anode is zinc, from the cell notation here. And then we substitute the value into the formula. E naught cell equal to E naught cathode, cathode first, and then anode. Cathode minus anode. Jangan terbalik. Cathode minus anode. So, both of the value for the cathode and anode here, both of the value here is from standard reduction potential. Okay. So, for cathode, positive 0.34. Cathode here. So, this is cathode. 0.34. And then for anode given here negative 0.76. So minus negative 0.76 is equal to positive 1.10 volts. Or if you want to use the second formula, also can. So kita write the equation oxidation and reduction. And then find E naught. To find E naught, we have to change the sign for zinc. Zinc here anode. Anode given before that, before this, the value given here there is for standard reduction potential. But then if you want to use the second formula, for anode you have to change the sign of the anode side, which is zinc. So the symbol here from zinc to plus slash zinc, it becomes zinc slash zinc to plus 0 plus 2, and then from here plus 2 to 0. So this is for SRP, standard reduction potential. So that's meant for reduction. And this one adalah untuk for oxidation number from 0 to positive 2 is increased. So that's mean it is oxidation process. So we change the sign for the SRP, from negative to positive. Okay, and then use the second formula, E naught reduction plus E naught oxidation. Reduction, correct, it is come from standard reduction potential. Okay, positive 0.34. But then for oxidation, okay, tak boleh ambil from the SRP. Okay, tak boleh ambil from the SRP, but ambil yang you dah tukar dia punya sign. Okay, so sebab tu madam prefer you pakai the first formula. That's mean ambil directly from the SRP values. Okay, so kita tak perlu tukar dah dia punya sign. Okay, tapi kalau nak tukar, nak guna juga the second formula, boleh. Okay, also can, but you have to change the sign. Okay, for the E naught. Okay, for SRP. Okay, so the final answer is the same. Alright, so kita tengok soalan yang pertama, test yourself one. Calculate the E naught cell for the reaction. So E naught, that means ini adalah dalam keadaan standard. Okay, so standard, okay, it should given here AQ 1 molar lah. Okay, ini medium terlupa. Okay, AQ 1 molar. Alright, so given that, okay, this is a value of SRP. Okay, macam mana kita tahu? Sebab both of the equation here given that in the reduction process. Reduction. Okay. So the answer is, write the formula E naught cathode minus E naught anode. Okay, directly we can take the values, okay, from the SRP table, okay, or from the SRP given there. Okay, so cathode here is tandem cathode, positive 0.15, and then this one is anode, okay, negative 2.38. So substitute the value and you get the answer. So don't forget to put the positive sign there. And second one, a cell is set up between a Cl2 electrode and a H2 electrode. Okay, that's mean we use here is platinum. Okay, so given E naught cell is positive 1.36, so this is voltmeter reading. A, draw a diagram to show the arrangement of apparatus and chemical use. Determine the standard reduction potential for Cl2 and discuss the chemical reactions occurring in the electrochemical cell. So given there is the cell notation. So the anode is hydrogen gas. So bila guna hydrogen gas, and then the electrode here we use a platinum, hydrogen gas. So this is the setup for the apparatus when we use the gases. And then this is Cl minus aqueous ion, platinum, chlorine gas. Alright, so here you must add electron flow, and then this one is cathode, negative, anode, positive, and label salt bridge. So from the cell notation, we know that this side is for anode and then this side is for cathode. Okay, use the formula E naught cathode minus E naught anode. Cathode here, okay, cathode, okay, the E naught cell here is positive 1.36. For anode, okay, for anode, when we see the SRP table, okay, for hydrogen is equal to 0, okay, 0 volts. That's mean E naught cathode is positive 1.36 volts, or we can write specifically Cl2 slash Cl minus. So make sure the oxidation number here is from 0 to negative is reduced. Okay, that means the cara nak tulis lah, okay, for SRP value. So positive 1.36 volts. Okay, so the standard reduction potential of Cl2 is positive 1.36 volts. And then how the operation of this galvanic cell. So the anode at the cathode, chlorine molecules gain electrons and undergo reduction to produce chloride ions. And the anode, the hydrogen molecules release electrons and undergo oxidation to produce hydrogen ion. Alright, next one. Calculate the standard cell potential of the following electrochemical cell. So the cell notation is given. So this is anode and then this is cathode. Alright, so this one is for standard reduction potential of silver and cobalt. Okay, from the equation we know that, okay, this is the half equation. And then we identify from the cell notation given, identify which one is anode, which one is cathode. And then write the formula, insert the values and get the answer. Positive 1.08 volts. Okay, so this one dia rewrite sahaja. Okay, rewrite half equation in reduction and oxidation. Alright. So before we proceed, so make sure do your homework, page 17 and 18. So let us continue. Spontaneous and non-spontaneous reaction. A redox reaction is spontaneous when E0 cell is positive and non-spontaneous when E0 cell is negative. So this one is for standard, okay, standard state. Okay, when the condition is in standard state, okay, untuk tentukan spontaneous and non-spontaneous, we look at the value or the sign for E0 cell yang kita cari. Okay, what about when E0 cell is 0? Okay, when E0 cell is 0, the reaction is at equilibrium. Alright, so for example, we have this question, predict the spontaneity of the reaction under standard condition. Alright, so from the overall equation given, identify, okay, first of all you have to identify which one undergo oxidation, which one undergo reduction. Okay, for here zinc, cari pasangan dia zinc and zinc 2 plus, so oxidation number increase from 0 to +2, so oxidation process. And then here is reduction process, oxidation number decrease. Right, so given here is the SRP value. Okay, here is SRP value. We check here 2 plus 2 0, 4 plus 2 2 plus. So this is SRP values. So rewrite the equation, half equation. Okay, zinc become zinc 2 plus, Sn 4 plus become Sn plus. So kita potong yang 2 electron and dapat the redox reaction. Okay, so E0 cell, okay, if you use the E0 cell equal to reduction plus oxidation, okay, so the oxidation you must change the sign. Okay, so reduction is positive 0.15 plus 0.76, so kita akan dapat positive 0.91 volts. Alright, so if you want to use the E0 cell equal to E0 cathode minus anode. Okay, so cathode here is positive 0.15 minus anode is negative 0.76. Okay, kekalkan value for anode, okay, iaitu yang ni. Ini dia tulis balik sebab this is the equation for oxidation, right? Okay, so kita akan dapat jawapan yang sama, positive 0.91 volts. Okay, just take the original value from the SRP. So when the E0 cell is positive, therefore the reaction is spontaneous. Okay, the next question, predict the spontaneity of the reaction. Okay, first of all, from the overall equation, identify which one undergo reduction process, which one undergo oxidation process. And then after that, write the equation, write the half equation. Okay, so here we use the second formula, E naught reduction plus E naught oxidation. Okay, that's mean here the oxidation dia dah tukar dah dia punya sign. So the answer is negative 1.49 volts. That's mean E naught cell is negative, reaction is non-spontaneous. Okay, so if you use the E naught cell equal to E naught cathode minus E naught anode. So just take the original value, E naught cathode is negative 0.13 minus the positive 1.36. Okay, so this one not from the SRP value, but then dia buat dalam oxidation process, so the sign become negative. And then write the oxidation and reduction equation. Okay, write the oxidation and reduction equation. So identify first. Okay, Ag to Ag plus, it is oxidation because the oxidation number increase from 0 to positive 1. And here, the oxidation number from 0 to negative 2. Okay, that's mean it is reduction. So oxidation and reduction. And predict the spontaneity of the reaction. Okay, from the value given, okay. So biasa exam dia akan bagi macam ni. Exam dia akan bagi equation macam dalam nota kamu tu, iaitu table yang equation tu dia tak bagi macam tu. Dia akan bagi half. Dia akan bagi yang diperlukan saja. Okay. So this is from SRP value. Okay. So here the formula used here is E naught cell equal to E naught reduction plus E naught oxidation. So the value here dia tukar daripada positive to negative. Okay, but then to be easier, you just use the E naught cell, E naught cathode minus E naught anode. So cathode, okay, cathode here reduction positive 1.07 minus anode, just take the original value from the SRP table given, so positive 0.8. Okay, so the value here is positive 0.27 volts. Okay, the E naught cell is positive, therefore the reaction is spontaneous. Okay, next. A cell consists of silver and tin in a solution of 1 molar silver ions and tin 2 ions. Predict the spontaneity of the reaction and determine the cell voltage. Ag plus, okay, dia dah bagi kat sini positive 0.8 and stannum and tin here given negative 0.14. Okay. So, predict the spontaneity. So, dia tak bagi cell notation and then dia tak bagi pun overall equation. That's mean, okay, kita tentukan which one is cathode and then which one is anode. Okay, so just take use the formula and substitute the values and get the answer. So, E naught cell is positive, it is spontaneous. Alright, so habis spontaneity and then turn to page 19 and answer the question, submit to me in GC. Alright, so sampai sini dahulu, kita akan jumpa lagi pada next video. Thank you.